What we want to do next is to look at the way of using MATLAB to execute a couple of commands in conjunction. So how do we do this? This brings us to the number 2, the second way of doing programming in MATLAB. And for this I make my MATLAB command window a little bit smaller, because now this is not where the things will happen. And in the home button on the top left, there is the possibility to select a new script. So if you do it with me, find it on the top left, and it's actually called new script. So if I highlight this, if I hover with the mouse of it, click on it, I will get a new window. The central window is now a new script window. And it's something that I can also address. I can also make it later. And I'll have a possibility to now enter a couple of things and execute them together in conjunction. So as one piece of code means MATLAB will execute any command that is in there until it reaches the end of the script. So we're now doing MATLAB execution of code via a script. And the exercise that we want to do, I have to introduce that briefly, is we want to bring up a new window. We want to do something that's very similar to what you're supposed to do in the first assignment of this, namely do a for loop to calculate the Fibonacci numbers. So we're going to do some slightly different thing, which is to calculate the Pell numbers. Maybe you've not heard that before, but if we type it into our web browser, you can see that the first entry that comes up when I type Pell numbers in my web browser is the Wikipedia entry on Pell number, and I think we can safely use that. What are the Pell numbers? To scroll down a little bit on the Wikipedia page, there's a definition of it. I'll try to make the window such that all you can see is the relevant part of it. Just checking. So now what you should see on your screen is Pell numbers are defined by a recurrence relation. So it's a very mathematical way of saying it. And if we interpret it, or if you just read through it, what it says below is a sequence of numbers that is as long as the number of natural numbers. So it's infinitely long in principle, but we can define, of course, any length of it. A sequence of numbers that starts with 0 and 1. That's what it says up here. It says the first number is 0, and the second number is 1. So it starts with 0 and 1. And all other numbers are calculated by doing what is here in that third line of the definition, namely referring to them as a sequence. So you have the first and the second defined already. So the next number will be calculated by taking the previous number, which is referred to as n-1, previous number times 2. Take the previous number, multiply by 2. So that's an instruction. Not yet finished, add the previous number, n-2. So if we would do it in our minds now, let's think of what is the third Pell number after 0 and 1. Well, you have to take the previous number times 2. The previous number is 1, times 2 is 2. So you have to take 2. You add to it the previous, or the number before that, which is 0. So you have 2 plus 0. Well, that's still 2. So the third Pell number should be 2. And if you look at the examples further down the line, there are some examples of the first Pell numbers, and you can see, you can see it starts with 0 and 1 as defined. The next one is 2, and then we have 5, 12, 29, 70, and so on. Now, of course, you can do it with a pencil on a piece of paper. You can just do it because this multiplication by 2 and adding another number is not very difficult. But if it comes to calculating 20 or 200 or 20,000 of those Pell numbers, you'd rather like to have some code to do it for you. So keeping this definition in mind, we can now try to implement a piece of MATLAB code that does it for us. And I'll try to keep it simple. And for every line, I will give a comment first. So a comment is started by percentage, and if I type percentage, you can see it's highlighted in blue in my case. This will be something, irrespective of what I say behind that percentage name, it will not be executed by MATLAB. So it means a comment is you can just write whatever you like to it. For example, something that helps you understand the code that follows. So first thing we want to do is set up a list of numbers. So just to say, we want to set up a list that is as long as the amount of Pell numbers that we want to calculate. So how do we do that? We need to assign it to a variable. Let's call that Pell, because Pell was the name of the numbers that we're going to calculate. So you use the variable Pell equals, and you say we want whatever comes next will be assigned to a variable called Pell. And we remember from the T previously, that is where all the numbers will be stored. So because we don't know the Pell numbers yet, we just make it a placeholder, and the placeholder is called zeros. So we just call them all zeros. So we make, how many numbers do we want to have? Say 20. If we want to have 20 Pell numbers, to say I want to have a single row of 20 numbers and all of them being 0. Now we want to test if this piece of code actually works. How can we do that? We need to execute this piece of code. And for this, I briefly bring back our functionality of the editor. Now we are in the editor tab, because we have a script that is now being edited, and in the editor screen there's a couple of green triangles pointing to the right, and they all have to do with run. Two things we can do. If we just want to execute all of the code that is there, we would just click run, just where my mouse is. If you can see where my mouse is, I just hover over it. It's the green triangle. In my case, it's just under the View tab. If you have the Editor tab highlighted, then there's a green triangle, and if you click on it, all the code that is in your script will be executed. So why don't we just do it? A new window comes up and says, actually give that script a name. So that's our Pell script, so we can call it Pell script. Maybe use an underline here. So I assign it the name Pell script, and if you click save, then that's what it does. This script will be actually saved, and if I go, you can see it's on my screen to the right of the MATLAB window. We now have a saved script prepared for execution as is. So I check, and if we look at our command window, click run again, what we can see is that yes, actually that piece of code, when executed by MATLAB by clicking run, produces a list of numbers, a list of 20 numbers, all of which are the same, namely they are all 0. So this is just a template. This is our starting point. This is now where we want to have all our Pell numbers filled in. So I make a new line in my code and putting it another comment, assigning Pell numbers 1 and 2. Remember, they were given to us by the definition of the Pell numbers. And so the definition was here that the first Pell number is equal to 0. So how do we access the first element of our list? We say Pell and then in parentheses 1. If you remember, T of 1 was the first element. So in this case, our first 0 is this one. And what do we do with it? It should be 0. Actually, we don't need to do a lot because that number is already 0. But for the sake of argument, let's just keep it there. If it was something different, that's how you would do it. The second element even was not 0, so that we have to now do explicitly. What is the second element? It's element number 2, and it's equal to 1. So if I clear my screen again, execute this code by clicking Run, then we have assigned Pell 1 equal to 0 and Pell 1 equal to 2. Where's our Pell 2? It's actually changed, so we can see our array still, or our list of numbers still consists of zeros, except for the second element, which we have changed to 1. Before we continue, it's an important feature to remember in any MATLAB code. If you want to see it in the command-like window like we are doing now, you can have the code as is. If you don't want to see it all the time in the command window, you can suppress this by putting a semicolon at the end of the line. So now that we have tested the code and found that it worked correctly, so far we can now put semicolons at the end of our line and say, okay, this code has been tested and we know it will work. The next time I execute it, it will work exactly the same. So now we're coming to the difficult part, difficult for those who haven't yet studied the material. We want to now find a way of instructing MATLAB to do a sequence of executions that one by one fills in the Pell numbers, starting with the third element, because first two we have already defined, starting with the third element and going all the way up to 20 without us having to do it individually, but do it in one go. So the way to do it is define a for loop. And for those who haven't done it, you need to read up a little bit on this. What is a for loop and how to define it? The for loop is a way of instructing MATLAB to do a number of commands in succession where they are all basically the same thing except moving from one place to another in a list of numbers as we have it here set up in the variable Pell. So our for loop would start with typing for, and then we have to define an index for the loop. So I arbitrarily use j, and I say for j equal 2, and then we have to define the range over which this j has to operate. So what are the numbers, what are the indices of the numbers that we want to fill in? We said starting from the third, going all the way up to 20. So we start with the third and we go all the way up to 20, and that defines for MATLAB which of those elements of Pell will have to be modified. So how do we do it? If I press return or enter, you can see that MATLAB automatically makes an indentation. The cursor now goes to the fourth position rather than the starting point, which makes the code more readable. So in this position now we put what MATLAB should do while it is in that for loop. What is the actual instruction? What does it need to calculate? So it needs to calculate the Pell number. And in order to know which of the one it is, we know we go successively from 3 to 20 by using our index j. So we calculate the Pell number j. Right? So the index j is now being used to say Pell number. Start with the third and go to 4, 5th, 6th, 7th, and so on up to 20. So we'll calculate all the elements from 3 to 20, the remaining 18 elements that we have not yet specified, but they're all still 0, as you can see at the bottom in the command window. So what do we have to do? We have to say 2 times the previous number. So how do you find the previous number? Well, knowing that j is the current number to be calculated, we know that the previous number is j minus 1. So take the previous number, which is Pell, in parentheses j minus 1, and multiply it by 2. Not quite finished. Then add to it the previous number, the number that was before the previous number, means in our parlance Pell j minus 2. Pell, sorry, I have the parentheses wrong, j minus 2. And I have to close the parentheses. And we can see that these two components, these two terms added together, were exactly what defined the mathematical terminology, recursive formula to calculate Pell numbers. And actually, it's not a coincidence that it was defined recursively in the mathematical terminology and that this turns into a for loop in MATLAB. This is not a coincidence. This is why mathematics can be translated easily into programming code. So having done this, we are finished, because that will go from 3 to 20, then we are finished. And ending the for loop is done by going to the beginning of the line and typing the 3 letters end. And if you see, when I typed end and pressed enter, there was a wiggle under the for, a red wiggle that sort of warned me that this is not yet closed, and this red warning under the word for disappeared now, means MATLAB is satisfied because it's on the spot while I'm writing the script. It's checking whether it's consistent, and it looks like in the moment this code is fairly consistent. So now, of course, we have to worry a little bit. Will that be okay? And there's not much to do in MATLAB when you start to worry, other than run the code and check whether any error messages come up. So what we do is, first of all, we clear maybe our command window down there, and then we press run and see what happens. So we can see that at the bottom a number of there's some output here, and we can see columns 1 through 8 first. And what we can see is that now we have a list of numbers, first line here, which goes up to 20. And we can see the last number is already fairly big. But the important thing for us to check, what are the first 3 Pell numbers? According to this here, there should be 0, 1, and 2. Well, that's exactly what we had expected. 0 and 1 by definition, and 2 we had checked it by calculation from the formula before. So what you can see, Pell number is an instruction that gives you number that get increasingly bigger, but bigger in a way that looks slow. Increases first. Between 0 and 1, the difference is 1. Between 1 and 2, the difference is 1. Between 2 and 5, the difference is 3. So the difference actually increases. And if you check the last number, what is it? The last number here is, if we just look at it, it's 6,625,109. And the previous number was 2,744,210. So the difference here between them is already on the orders larger than 1 million. Now, what is it? 2 to 6 is more than 3 million. So a difference of more than 3 million means also the numbers get very big, but also the difference between numbers getting very big. So it looks like we have a good set of instructions, our MATLAB code to calculate the Pell numbers. And that's what you're supposed to do for this assignment with the Fibonacci numbers. The recursive formula is a little bit different, but I'm sure you'll be able to do it. So let's just stop this by looking at a plot of those numbers. I wanted to clear my command window so to have a plot. So we need to know what to plot. Plot takes as an argument the list of numbers that you want to see plotted. So in our case, it's called Pell. So in parentheses, I put plot round parentheses Pell. And now this is our final thing to do. If you do this, you should get figure number 1. And you can see this figure is maybe not very optimal. It's a bit small, and we can't really read the number. So there's a very important thing for you to learn. On the top right of this figure window, there is this somewhat square in a square window, which you can simple click on, and you will go to the interactive graphical user interface to deal with plots. So I'm not going into the detail, but I'll just show a couple of improvements. This is something that you really need to practice with, get used to it in order to make your plots nicer. So for example, clicking on one of the numbers gives you access to changing the font size of it. If I just click on font and I just make it quickly, choose a font size that is much larger than the one before, we can see we have the horizontal line, which is our index, namely our numbers that go from 1, which is somewhere here, to 20. So the plot actually starts at 1 because our first element is number 1. It goes all the way up to 20. So our 20 Pell numbers are, this is the index of the numbers, and the numbers are plotting on the vertical scale. And because we are forewarned, we knew that the last number was on the order of million. It actually is not 8, as you might see from the number here, but it's 8 times 10 to the power of 6. So that's actually in the order of millions that we can go already. And what you can see that this plot is something that looks like very flat at the beginning, and at some point, maybe here around 15, these numbers start to get bigger and bigger and actually explode and go into the millions. And you can guess that if you go even farther, if you calculate 30 or 40 Pell numbers, this will get enormously big. So one thing that you can do if you have numbers that get very big and you think that plot is not nice because it actually doesn't show a lot of this, you can try to look at it logarithmically. Make a logarithmic plot. In this case, take the logarithm of the vertical axis. How do we do this? We have access to the axis here. There's an x-axis. If I click on it, it's highlighted in blue. And then we get access to the x-axis. And the one thing that I want to highlight, you have the possibility of the scale. X scale can be changed from linear to logarithmic. Linear is just called linear, but if you want a logarithmic plot, and I'm actually doing it wrong because I said the vertical axis, not the horizontal axis. Vertical axis is called the y-axis, so the other 7 million that we have. So if we want to see that logarithmically plotted, we click on log, and what we can see, that changes our plot interactively immediately. And if I make this just a little bit bigger, then you can see our plot now turns from slowly increasing to exploding graph that we had previously into a straight line. So in a logarithmic display, you can see the logarithm here on the left side, 0, 2, 4, 6, 8. Then we get from the exploding plot, from the exponentially exploding recursive formula that we had, we get a linear plot. So Pell numbers plotted semi-logarithmically as we have it here will give a line. There's also a way just to quickly finish this. This graphical user interface under File has the possibility to save. So if you wanted to save this plot, say for sending in the assignment, under Save As, you could save this plot in some format, and MATLAB allows almost any format that you can use from the menu that shows up. You can use PNG or PDF or SVG or TIFF or whatever. Say if you use PNG, so we can just use it, give it a name, my Pell plot, assigning it a name, and then in addition to the code that we had, if I just take this away, it will show up on my desktop as an image that you can click on and work with it, maybe include it in your upload document that you want to hand in as an assignment.